Hello everyone, I'm Stefan again, and I'm going to talk about in this tutorial about finding the domain. The reason I'm focusing too much about the domain because it's really important, because if you have the domain wrong, you have everything else wrong, like it's the base. So we're going to do these examples because those they have the most restriction that you will find when you're finding the domain. We're going to do this all of them one by one, and then you understand what I'm talking about. So let's go start with the first one. We'll call it number one, and it's going to be f of x is equal to square root of x squared minus 2x over square root of 5x minus 1. So we're going to find the domain. So let's some explanation. The domain is where is the restriction. We have to find it and exclude it from real numbers. For example, here the first one, this number here shouldn't be negative because inside the square root should be always positive. So let's see where is this is going to be negative. So we exclude it. So we have x squared minus 2x should be bigger or greater or equal to 0. Therefore, x times x minus 2 should be equal or greater than 0. If you see this here, it's getting a little bit tricky. Sometimes you get maybe a temptation, so you can do this. You can do this. Therefore, x should be bigger than 0 and x bigger than 2. So what are you going to get from 0? Go here to infinity, and here 2. So say here is x has to be bigger than 0 and this. So you will take this from here to here, and you think you already find the domain, but it's wrong. It's not like that. You have to study each function by itself. Just I would like to warn you about that. This is wrong. So the way you do it, in my opinion, I study each function by itself. So the best way to do that, just make a table. So let's do a table like this. Can put x here, and we put x, we put x minus 2, and we put all the functions here. So let's see where is positive, where is negative. Let's put infinity here and plus infinity here. So this one is equal to 0. Where is equal to 0 and 0? So 0 here. So give us this is equal to 0 as well. And the other one, this one here, is equal to 0 when x equal to 2. So put number 2 here, and give you 0 here. So let's do each one by itself. This one here is going to be negative here, will be positive, they will be positive. The other one is going to be negative here, and positive. You are not sure, you just give a value and they will give you the answer. So if we see here, we see that are positive here, because if you multiply positive, multiply and positive give you positive. Is negative here and positive here. So from here we see that the answer is going to be this part here plus this part here. So the answer is here and this one here. There with this function is bigger than 0. Therefore the answer on the top should be x belong to the domain negative infinity 0 union negative 2 infinity. This is the first part. Let's see other part. The second part, we have we have 5x minus 1 should be bigger than 0, shouldn't be equal, because the bottom here, the first one we say bigger or equal, greater or equal to 0. The second one should be greater than 0, because the bottom shouldn't, the denominator should be bigger than 0 always. So it's going to give us here, therefore 5x should be greater than 1, therefore x should be greater than 1 over 5. So we have here, and this one it will be x belong to 1 over 5 plus infinity. So now we can do this here. We can imagine all of them in one time. We can put a line like this. So we have the domain for the first one. We change the color here. For the first one, we have it from, we say from negative infinity. We say this is negative infinity, and we have infinity. And this here we can put 0, and we can put 2. So the part where is the function is defined, the first one is here. Here is a function. Second one, we can put, change the color here. The second one we say has to be bigger than 1 over 5. 1 over 5 is here, is between 1 over 5. So the domain, so from 1 over 5 goes to here. This is not included. All this from here. So from here we see the domain, it will be this from here and go here to infinity. Therefore the f, the domain, is equal to infinity. So this is the answer for that. The reason why, because we have many restrictions. We have restriction on the top and the restriction on the bottom, and the answer where is they are combined, they are both of them defined. It has to be this part here, no more. It can be this, can be this, because it has many restrictions. You have to know where is both of them, define both of them. So this is the domain for the first one. So let's find the domain for the second one. So the second one, we have the tangent. First of all, where is the tangent equal 0? We have to exclude these points. We know the tangent of x is equal to 0 where is sine equal to 0, sine x equal to 0. Therefore tangent x is equal to 0 at 0 and pi, and always when we have in those functions like that is keep going. It will be 0, pi, 2 pi, and keep running like this. It never stops. So therefore, and we this is the first step, and what we have to, and we know that the tangent of x is undefined at pi over 2 and 3 pi over 2. Why? Because the cosine on those points, cosine of x is equal to 0, and tangent of x is equal to sine of x over cosine of x, and this can be 0. Therefore the tangent is undefined in that point. So let's see what is the domain. So we have to exclude those points, that's 0 and pi over 2. So we're going to put a circle and visualize what is going to happen exactly. So we have this circle here, put the center here. Let's move it a little bit. So we have here, we have 0, we have pi over 2, we have pi, and we have 3 pi over 2. We see that this function is restricted here, shouldn't be equal to this, and shouldn't be equal to this, and shouldn't be equal to this, and shouldn't be equal to this. That's the restriction. So what does it mean? So we see, so the restriction is going to be 0 plus, if you move from here to here, it's just pi over 2, and then if you move here, you already moved another pi over 2, you move to another pi over 2, you move to another pi over 2, you move to another pi over 2, and keeps going forever, never stops to infinity. So therefore we see the domain, the g is just equal to negative infinity zero plus n pi over 2, and n is integer. So what does it mean? So is 0, 1, 2, 3, and on, keep going. So therefore this is the domain, therefore it will be negative infinity n pi over 2 union in pi over 2 infinity. So this is the domain. Let's see, explain it in the circle what is going to be exactly. So if we got a circle here, so will be when n equal to 0, it will give us 0 here, you see. When n equal to 1, it will be pi over 2 here. When n equal to 2, it will be pi. When 3, it will be 3 pi over 2. You see, this means this is the right answer here. You can visualize it. When 0 is here, when n equal to 1 is here, and here, and keep going without stopping. If you see here, if you give n 0, it will be here, and 0 means is everything, this number here is going to be 0. When n is 1, 1 multiplied in pi over 2 is just pi over 2 is here. When n is 2, it will be 2 pi over 2, it's just pi, it will be here, and keep going. So this is the domain for this function. It was a little bit confusing, but it could be done. So let's do the third one. We have Rx is 1 over log the base 10 of x. When you see log like this, means the base of 10. So what is the domain of the log, the logarithm? The domain of the logarithm is all real, all positive numbers exclude 0. So the domain log x is equal to 0, infinity. So all real, all except 0. However, we see here is a restriction. This here shouldn't be equal to 0, because the denominator shouldn't be equal to 0. And we know log of x equal to 0 when x equal to 1. Therefore, we should remove the 1 from here. From here should minus 1. 1 shouldn't be included. So therefore, the dg, the domain and this function of Rx, domain of Rx is going to be 0, 1, union 1, infinity. Was easy. Let's go to the third one. So we have in this case, where is this function restricted? Here on the top is okay, just polynomial, could be any number, all real numbers. However, in the bottom we see that square root of x minus 1 should be positive and shouldn't be equal to 0, so it will be greater than 0. However, we know that x minus 1 is always greater than or equal to 0. Doesn't matter which numbers. So therefore, the only restriction we have in this case, that this here shouldn't be equal to 0, because they are always positive, and this shouldn't be equal to 0. Therefore, x minus 1 shouldn't be equal to 0. Therefore, x shouldn't be equal to 1. If, for example, we have this function like this, just for example, x plus 5 over square root of x minus 1, it will be everything different, because this could be negative here inside, it could be negative. We have to take this, we have to take where is not a restriction, where makes the negative. It will be, for example, from negative infinity to 1, it will be excluded. But in this case, since we have the absolute value, is still included, because is never negative. Therefore, the domain of this function dq of x is just equal to negative infinity 1 union 1 infinity. Hopefully this lesson or this tutorial was useful for you, and thank you for watching, and wait for next video. Please subscribe and share, and thank you.